Okay, so this is question 8 of the 12.1 homework. And so what we're going to be looking at here is the claim that someone is making is that more hockey players are born in January through March than in October through December. And so, let's see. And it says, is there evidence to suggest that a hockey player's birth date is not formally distributed throughout the year? So that is going to be our alternative hypothesis right there. So this is what we're going to be talking about, that either that our null is that they are uniformly distributed and our alternative is that they're not. So even though at the first it states that that the book claims this, that's not what we're testing. So that gets a little bit confusing. Okay, so now we need to find the expected count. So our expected count is what our null hypothesis is. So our null hypothesis, our null hypothesis is that the distribution of the birthdays is uniformly distributed. And what uniformly distributed means is that it is exactly the same. So in this case, they divided up the months into categories of 4 different categories. And so basically a quarter of all of hockey players are born this month, a quarter is born in that month, a quarter born in that one, quarter born in that month, or 1/4, or 25%, whatever you want to say, it's all the same. And so how we're going to calculate that is, it has these blue boxes, which we love, so we don't have to do it ourselves. And StatCrunch has this button that I'll show you guys. So we're in goodness of fit. We know that that's what we're doing because if it says view the chi-square table of critical values, that's a Q. Plus we're just in 12.1 anyways, and we have the observed and expected values that we're figuring out, and so that is why we know we're in goodness of fit. And chi-square test. The observed is the frequency, and then we can select this button, all cells in equal proportion. What we could do is we could add all these up and then times that by 0.25 to figure out what 1/4 of it is, or divide it by 4, and then it would be the same numbers all down. Or we can just do that and it does it all for us. And so this expected should be the same number, just like it is, because our null is that they're all the same. Oh, that one didn't get a decimal. Oh. And then the test statistic is just this chi-square number right here. It's kind of confusing because it's not labeled test statistics. So that's just something that you'll want to remember if you want to jot that down in your note card. That might be cool. I don't know how many of these questions will be on the test, but if you have a hard time remembering that, I might want to do that. Our p-value is pretty low. And let's see, we're seeing basically right here they're asking us if we should reject or fail to reject the null hypothesis, and it's the same rule as it always has been. If our p-value is greater than the level of significance, then we're going to fail to reject the null, and if it's less than, like it is in this case, if it's less than the level of significance, we will reject the null hypothesis. So do the hockey players' birth months follow uniform distribution? So this right here is what our null hypothesis was. So that's just a fancy way of, a longer way of saying our null hypothesis. And we said that we're going to reject it. So no, because the p-value is less than the level of significance. And that's all it is to that one.